Okay, hello students. This is Algebra 2 Unit 9, Unit 4, Lesson number 9. And the topic of the lesson is what is logarithm? The goal of this lesson is I understand that logarithm is a way to represent an exponent in an exponential equation. So let's see what at the end of this lesson we need to understand that logarithm is just kind of a representation of the exponential equation. So how does that work? We will see. Now let me dive down straight away to the first task. Students task is 9.1. Question is find the solution of each of these four. The first one is 4 raised to a is 16, and you can clearly see this. What number? That means 4 raised to 1 is 4, correct? 4 raised to 2 is 16 because 4 square is 4 times 4, and 4 cube is, if you multiply another 4 it's like multiplying another one. So the two fours, when you multiply, you already have 16, and you multiply another 4, you get 64. And if you multiply one more times, that is 4 cube, 4 raised to 4, you end up multiplying, you end up getting 256. So here the question is only asking is what is this a? And you can clearly see the 16, this is possible only when your a is 2. So here the answer is 2. But is there another way to do this? You could also do the same thing uh, by replacing. We know 4 is 2 square. So 4 is 2 square raised to and the a, and 16 is 2 raised to 4 because 2 times 2 times 2 is so 2 when multiply itself 4 times we get 16. So and now this you can use property of exponent, which is 2 times these two pieces multiply, get 2a, and you get 2 raised to 4. Now you have the same bases. If the bases are the same, okay, that means these two exponent has to be equal. And when you do this, you get divide by 2, you get a equals 2, and you're done. So two different strategies you can use and get the answer. Another strategy also you could use is this is 4 raised to 8. It's like you graph on the Desmos uh, calculator 4 raised to x function, and you'll see there's a graph going like this, and you want to know when is this going to be another function, which is y equals 16. So maybe y is 16 here. So this will be y equals 16, and you'll see there is a point, and you see this point will be, you'll see this is going to be 2. So 2 and this is 16. So graphical approach also can be done. The second one is, what is this, right? So 4b is 2, and we know 2 is square root of 4, okay? And square root of 4 is written in the rational exponent as 4 raised to half because there's a 2 here. Now if you compare this, b, so this 2 is exponent here, so b becomes equals to half. So this is one approach to do this. Or you could also say, okay, we can use the same strategy like the one I did before. 4 is 2 square, and this is 2 raised to 1. And this is multiply the 2 exponent, you get this way. So you end up getting the base is the same. This is 2, so the exponent has to be equal. So 2b is equal to 1, and dividing by 2, you get b is half. So that's how you can do the problem. And you can use the same idea about in Desmos also and figure out that way. Let's do the third. So now they give us 4 raised to 5 by 2. So the question is, so will you use the first, I will use a different approach. That means we can write this as 4 raised to half times 5. This can be written as 4 raised to half, and then the 5, by using the properties of exponent, power of power, we can write is this one. But we do know this is square root of 4 raised to 5. and square root of 4 is 2. So you get 2 raised to 5, which is if you multiply itself 5 times, you end up getting 32 and you're done. Another way to do this would have been, what about, let's see if it is 4 is 5 by 2. Okay, we could write 4 as, see this, so the 4 that you see here, we can write is 2 square. Now this gives you straight away, you multiply the exponent, power of power, okay, so this 2 crosses out, you get 2 raised to 5, and you will end up getting the same thing. Another approach would be, maybe you want to write 4 raised to 5 here times half. So that will be a little difficult. Let's see what we get, end up getting raised to half, like to see. And if you do that 4 raised to 5, you kind of get 1024. So you can always check with the calculator, and which is raised to half. And this is actually square root of 1024, and you get 32. So this becomes a little hard to do, but I would say these two are easy. Let's go to the next activity. So before we do 9.2, I will just give you a brief background of what we learned in lesson number 8. If you remember lesson number 8, we had a table like this way. Quickly, let me show. So with x and 2 raised to x here, the y, output y is 2 raised to x. And when you put 0, we got 1. When it was 1, it was 2 raised to 1 is 2, 2 raised to, so if it was 2, this is 2 raised to 2, which is 4, and so on. If it is 2 raised to 3, it was 8. If it is 4, it was 2 raised to 4 is 16, which is 2 raised to 4, okay? So, and if it was minus 1, 2 raised to minus 1 is 1 over 2. If it is minus 2, it is 1 over 4. So what's happening is here is this x, whatever the red x that you see, it goes here, right? Now what we do the next one is have another table where you swap the, see, see this one. So this is, instead of these two pieces, the input output, I want to make it output input. So this 1/4 will go here, and then half. So output becomes the input, and the input that you see here, the red, this minus 2 maybe minus 1, 0, 1, 2, 3, and 4. So they will be here. Okay, so you're swapping the x and y. So if this is x, now the new one that I have is, instead of y equals 2 raised to x, so now we have x equals, okay, 2 raised to y. So the red color x, this x is, okay, is equals 2 raised to the y. Let me use the black color for this one, see. So the black color 2, the 2 is the base. The base use is 2. So that's the important uh, concept there. It's because of the base 2, this because of the base 2. So you end up getting the output 1/4 and all these numbers, okay? But now you want to swap this and say you want to undo the thing. Suppose it means if it is 1/4 here, if this is 1/4, you get -2. But what is the new function? So we want to create a new function here that takes back to you. So if this piece goes, let's take this one. So if 2 goes to 4, so look at this, 2 goes to 4 here. So 2 goes to 4, but here 4 takes it 2. So now we need to create a function. What is that way out to write this? And because this we can come. So in this example, hey, we need to create a function that, what is that new function? And that's what we are thinking. The mathematician by name Logarithm, he decided, he said, hey, let me create a function that takes back 8 to 3. So you want to get 8 to, he wants to take it back to 3. So he used his first three letters and say, okay, let me use log, and the base use is the black color 2. So the black color 2 is right here. Okay. And then you say, okay, what is that you want to take back? So it means this blue 4 which is here, put it right here. And the answer is 2. Mm, So the red 2, see. So mathematician logarithm, he used his first three letters as a to create a new function, and he used this. So basically, logarithm, this logarithm right here, you see, is basically you get. Let's take. Okay, I think I use both two, and that's create a problem. So let's see if I can use. Let me use another one. Okay, okay. So what I'm trying to say, let's see use this piece. 3 takes you to 8, and 8 takes back to 3. So this 3 takes you to 8. What does it mean is 2 raised to 3 is 8, right? So we want to go back, go take, how does 8, uh, 8 takes back to 3? Because this 3 takes to 8, and 8 takes back to 3. So we use, so the mathematics, as I said, the logarithm, he say, okay, this become the input, so that's like a x. So he say, okay, log, and the base that we use is the 2. So the base is the 2 here. Log base 2, and the input here was 8. So the question is, logarithm base 2 to 8 is, the answer is 3. So what does the log basically means is, this is representation of the same equation exponential function. This exponential, that means you are raising the base, the black, this two you raise to this 3 is the 8. It means logarithm is log to the base 10 of anything is a value, that means whatever this value, which when raised to 2 gives you this number. Okay, let's go back to the activity. So the question number 9.9.2 is, you're given a table and the question is asking, can you analyze the table? By just looking at this, what do you observe? Okay, you can pause the video for a while and write down on your packet that you have as, hey, what do you see here? You can see there are four tables. There's one here. There's one. It's a continuation. This table is the continuation of in between. There's a jump here. Okay, I want you to think that. Look at these four tables. And what you observe is the input. So these are four tables, right? And the input I'm going to use. Let's see all these numbers. I want to focus on this color. See this? All this number. What do you see here is, in the first one, they are single number 2, 3, 4, 5. In the second table, the input that you see, this is the input, right? The input in is there's a 10 or multiply by 10. So if this is 3, this is 30, this is 4, this is 10. The next one is 200. So if you see each this third table, you're multiplying by 100 to the first one. So from first to the second one, it is times 10. From here, you multiply 100. From here, you multiply by 1,000, you get 2,000. So that's an observation there. And another observation you see is all the outputs that you see. Look at this, all this output that you see, this output, they're all in the decimal form. And another thing I want you to analyze here also is how they grow. Watch this. This is 0. This output is 0.3010. This is added 1 to it. Here you add 2 to the original one. See how? So it is adding 1. This is adding 2. This is adding 3. And so when you're the output, you're adding 1, but and the input you're multiplying by 10. So if you see this, so this one from here to here, you're multiplying by this 2 is multiplied by 10, and this one you add up. So the output is adding up 1 when the input is multiplied by. And notice the last row here, in this case, uh, and everywhere there's a log base 10 to x, log base 10 to x. So all these 4 pieces, so that means you're every time you're plugging in the log. Let's see, I want to put this one. It means log of 5 is, so logarithm, log to the log base 10 of 5 is 0.690, right? If I want to write this, what does it mean is log base 10 of 6 is another fraction. Okay, and then the last one you see, observe there is at the end you will see log base 10 of 1. I'm talking about this piece. Okay, let me take off all this and just focus on the one that we have at the bottom. Okay, so the first one, and you can see if the input is 10, you plug it here, x is 10. So log base 10 of 10 is the one, this one, right? And let's see this one. What does it mean? You plug in log base 10 of 100 is, and the answer is 2. The third one is log base 10 of 1000 is 3. And the last one here is log base 10 of 10,000 is 4. Now you see the relationship that you see by just looking at it. You have to analyze that. Um, what do you analyze here is, okay, think of like a color. Let me put the base black 10. So this is like a black 10. The base is this is the 10. Everywhere you see this black 10, right? And let's use, this is 1, 2, 3, and the black. Okay, and the other numbers we can use the blue, maybe some other number. Okay, so what's happening here is, what is that you see here is, what strikes your mind is, let's take the bottom part. If you see this piece, what comes to your mind is there are 4 zeros there. So you see there are 4 zeros. If there are 4 zeros, then the answer is 4. If there are 3 zeros, the answer is 3. If there are 2 zeros, the answer is 2. If there is 1 zero, now how did we get that from? If you see this piece, this piece basically means the base 10, this base 10, this black, let's put it black color, base 10, this raised to the power, the red 4 equals the magenta color, that is 10,000. See? So that's the understanding. So this piece is the same thing, because you can see it is really true. And if you want to figure out the other one, so the goal of the lesson is this only. So this piece that you see, the second part is, it is the black color 10. The base is 10. This is the base is 10. So this is the base 10. So I'm using, okay, 10 raised. So whatever the answer that you have, the red 3. So this is, so the log gives you the value 3, uh, which when raised to the base gives you back, gives you the 1000. See? So I want you to focus what I'm writing here. So both log of the new function. So this is a like creation of a new function. This log that you see is a creation of new function. And if you see the top one, the another one that we have here, this piece, the value 2 is, so we can use a logarithm. So let's put a logarithm, log base the black 10, and you can see, sorry, it means you are using the black 10 raised to the 10 raised to this 2 equals the black is 1000. See, 100, sorry. So 10 square. So this piece is written in the equation. So what is logarithm? This new thing is it basically is creating it's a representation of exponential equation. So this is exponential equation. So this exponential equation is because of this log. So it's something new that is created. This is something new, but this something new is because of 10 square is 100. So I hope I'm making sense here. To understand what is, the question is what is logarithm, right? So logarithm is whatever the value that you see, let's see the value, log is, so if I write log base 10 of let's put it like 100. So it means it's the value, whatever the value, whatever the number, it's the number when raised to the base 10, that is this 10, and you want to raise it to this value, whichever that is, we don't know, let's put it P, and I will just put P, that is 100. So you want to know what is that P? So when raised to the base 10 gives you 100. So that's an idea. Now, if you go back, now there's one more question there. Now, from the table, use the table. You're supposed to use the table to find the value of unknown exponent that makes each equation true. Let's see, suppose you have 10 raised to w. Now, I want you to look at this expression is basically log, and the base is the 10 of 1000 equals w. So this is this is a log is a representation of this uh, exponential equation. So this is exponential equation which changes to log 1000. So from the table, if you see, uh, so when 1000, so where is that on the table? If you see that like this way, 1, and you will see there is at the bottom the third table, if you see there is a, this is x and this is log x to the base 10, you see this answer is 3. So that means this answer is 3. So from the table, of course, our common sense, you already know that 10 times 10 times 10 is 1000, right? So it is 10 raised to 3. So it has to be the w that you see here has to be 3. Look at the second one. So on the table, if you see, this is can be written as in the log expression. It means it is log to the base 10 of 9, and this is that y. So we want to know, look up from the first table. If you see the first table here, where is that 9? And you'll see there is a 10 here and there is a 9 here, and the 9 gives you the answer as 0.9542. So this answer that you see is this 0.59542, and that's it. So you're just writing this in the logarithmic form, log form, and from the table, or you just have to figure out, hey, where is this 9 in the over here? Now, if you see the next one, you see you will see there is the second table. You will see 90. So if this is 1000, there is 90 in the second table, and you see 90 takes the answer to 1.9542. So that means it has to be 10 raised to this number, because this is x and this is log x base 10. So 1.59542 raised to 1.954. This is the only way you get 90, because this expression is written as logarithm log base 10 of 90 is 1.9542. So I hope it will take a little while to understand this, a little confusing, but just use the changing the expression. So this expression and this expression means the same thing. The table gives you already the log. So all you do is you change, if they are given, let's imagine if they had to give us 10 raised to, let's put it like 10 raised to the p equals uh, so if you were given this, now how to find from the table what is this, what should be p? Now from the table, uh, all you go is look out for the table, the one that has 5,000 here, somewhere 5,000 like this. So if you see this 5,000 means this is x and this is log of x to the base to 10. So 5,000, if you see from from your table, you can check this. This is given as 3.66, sorry, 3.6990. So that means so you look out for 5,000, that gives you this. So that means 10 raised to 3.6990 is 5,000. Or if you get confused, all you do is this piece that you see here, this piece, you can write in the log form and say, what's the log to the base 10 of 5,000? Okay, 5,000 is P. So, and then you find out, okay, so there is that 5,000 on the table here, and you get that 3.66, which I'm talking about, this P, which is 3.69990.